In this module, I am talking about some MCQ questions related with the colligative properties. Question 1. Colligative properties are properties of solutions which depend on. So, the question is saying about colligative properties. Let me explain first the meaning of colligative properties. For this, I am considering a vessel which contains water. So here water acts as solvent. In the case of water, vapor pressure at room temperature is 23.8 millimeter. Boiling point you see 100 degrees Celsius. Freezing point it is 0 degrees Celsius. Osmotic pressure it is equal to 38 millimeter. Then what I am doing next is dissolving 10 particles of sucrose. 10 particles of sucrose. Then we get a solution, sugar solution. Then for the solution, I am again measuring these values. Vapor pressure is found to decrease, suppose decreases to 20 mm, then boiling point you find increases to 103 degree Celsius, freezing point you find decreases to minus 2 degrees Celsius, then osmotic pressure found to increases to 44 millimeter. So the lowering of vapor pressure we can write it is 3.8. Usually we write lowering of vapor pressure as relative lowering of vapor pressure, RLVP, relative lowering of vapor pressure. It is obtained by dividing lowering of vapor pressure by original vapor pressure 23.8. Then increase in boiling point. Increase in boiling point, here we say elevation of boiling point. Elevation of boiling point, here it is 3 degree Celsius. Then we have a decrease in freezing point, here we say depression of freezing point. Depression of freezing point. Depression of freezing point, it is depression of freezing point means decrease in freezing point. Here it is 2 degree Celsius. Osmotic pressure change it is 6 millimeter. 6 millimeter. So we have 4 properties: RLVP, elevation of boiling point, depression of freezing point, and osmotic pressure. Here then see I am repeating the experiment by replacing the non-volatile solute. Instead of 10 particles of sucrose, in the next experiment I am dissolving 10 particles of urea. Again I am repeating the experiment by using another non-volatile solute, 10 particles of glucose. Then measuring these 4 properties: RLVP, elevation of boiling point, depression of freezing point, osmotic pressure. All these properties, the same observation I got in the second and the third experiment. Same values. RLVP 3.8 divided by 23.8, elevation of boiling point 3 degree, depression of freezing point 2 degree, osmotic pressure 6 millimeter. Means It means these properties depend only on the number of particles and not on their chemical nature. See, in 3 experiments, I am using the same number of particles, 10 particles of sucrose, 10 particles of urea, 10 particles of glucose, but I am changing the nature of solute, sucrose, urea, glucose. But the change in the nature of solute cannot affect the values of RLVP, elevation, depression, or freezing point, or osmotic pressure. It means these properties depend only on the number of solute particles and not on their chemical nature. Such properties of solutions are called colligative properties. So colligative properties are properties of solutions which depend only on the number of particles and not on their chemical nature. Now let me write some conclusions about colligative properties. I mean the factors on which the colligative properties depend. We have 4 points. First one, colligative properties depend on number of solute particles, but colligative properties do not depend on nature of solute particles. Then what about solvent? Colligative properties do not depend on number of solvent particles, but colligative properties depend on the nature of solvent particles, nature of solvent. So the first 2 points are about solute. When we talk about solute, colligative properties depend on the number of solute particles, but they do not depend on nature of solute particles. When we talk about solvent, colligative properties do not depend on number of solvent particles, but depends on the nature of solvent particles. With this idea, we shall check the options one by one. Option 1, here it is, the number of solvent particles, incorrect. Number of solute particles, correct. Nature of solute, it is not correct. Then third option, number of solute particles, correct. Nature of the solvent, correct. So the answer is third one, option 3. Okay, this is the answer. Third one is the answer. Question 2. Which of the following is not a colligative property? We have studied there are 4 types of colligative property. First one is relative lowering of vapor pressure. Second one, elevation of boiling point. Third one, depression of freezing point. Fourth one, osmotic pressure. So we shall check the options one by one. Vapor pressure. Option 1 is vapor pressure. It is not a colligative property. Actually, relative lowering of vapor pressure is the colligative property. So it is not a colligative property. Elevation of boiling point, it is a colligative property. Depression of freezing point, colligative property. Osmotic pressure, colligative property. The question is asking which is not a colligative property. So answer is 1. Okay. Question 3. The vapor pressure of a liquid is the pressure exerted by. See, suppose there is a vessel which contains a liquid. Above the surface of liquid, you can see vapors. When liquid and the vapors reaches equilibrium, the quantity of vapor above the surface of liquid remains constant. Then the pressure exerted by the vapor on the surface of liquid is called vapor pressure. So what is vapor pressure? Pressure exerted by the vapor on the surface of liquid at equilibrium state at a given temperature. That is the correct definition of vapor pressure. So we shall check the options. First one, the vapor pressure of a liquid is the pressure exerted by first one, which is given pressure exerted by atmospheric air. It is not correct. Second one, pressure exerted by the vapor on the surface of liquid at equilibrium state at a given temperature, correctly given. So option 2 is correct. Okay. Question 4. The boiling points of C6H6, CH3OH, C6SYNH2 and C6SYNO2 are 80 degrees Celsius, 65 degrees Celsius, 184 degrees Celsius and 212 degrees Celsius respectively, which will show highest vapor pressure at room temperature. So, we know a relationship between vapor pressure and boiling point. Vapor pressure is inversely proportional to boiling point. It is inversely proportional to boiling point. As boiling point decreases, vapor pressure increases. So, out of these four compounds, which will be having lowest boiling point, if you go through these lines, we find that if we find a temperature 65 degrees Celsius, it is the lowest temperature. It is possessed by CH3OH, methanol. So, methanol with the lowest boiling point. It shows highest vapor pressure. So, option 2 is correct. Then next question. Question 5. Vapor pressure of a liquid decreases. Here you can see different options. To find out the correct option, we should study or we should have the idea of the factors on which vapor pressure depends. Vapor pressure directly proportional to temperature. When you increase the temperature, vapor pressure increases. When you decrease the temperature, vapor pressure decreases. Also, vapor pressure is inversely proportional to intermolecular attraction. Intermolecular attraction. So, in the case of liquids, where intermolecular attraction is greater, vapor pressure is less. So, we have three relationships uh, for vapor pressure. First one is we have already seen vapor pressure boiling point inversely proportional. But if you take temperature condition, vapor pressure temperature are directly proportional. Then nature of liquid, vapor pressure is inversely proportional to intermolecular attraction. With this idea, uh, we shall check the options one by one. First, Vapor pressure of a liquid decreases. They are asking decreases. Surface area of liquid. Surface area has no role in deciding vapor pressure. So it is incorrect. Volume of container. It is also having no role. Volume of the vapor phase. It is also having no role in deciding vapor pressure. Temperature is decreased. Correct. As you decrease the temperature, vapor pressure of liquid also decreases. So correct answer is fourth one. Okay. Now moving on to question 6. Vapor pressure of liquid depends only on. We have already discussed how vapor pressure changes. Vapor pressure changes inversely proportional to boiling point. Vapor pressure directly proportional to temperature. Vapor pressure inversely proportional to intermolecular force of attraction or nature of liquid. It represents nature of liquid. So we have only three factors on which vapor pressure depends. Boiling point of liquid. It also something like nature of liquid. Nature of liquid. So about nature of liquid, we have two factors deciding vapor pressure. Liquids with higher boiling points will have a lower vapor pressure. Liquids with a higher intermolecular force of attraction, they also have lower vapor pressure. Then another, so first one and the third one talking about nature of liquid. Then second one, it says as you increase the temperature, vapor pressure increases. So we have three conditions on which vapor pressure depends. With this idea, we shall check the options. Vapor pressure of liquid depends. Surface area of liquid. It is incorrect. It has no role in deciding vapor pressure of a liquid. Temperature correct. Temperature will decide vapor pressure. Nature of liquid. It is also correct. Intermolecular attraction. Liquids where intermolecular attraction is greater. Vapor pressure is less. So it is also correct option. Therefore, answer is fourth one, both 2 and 3. Okay.